and a very good morrow to you guys. Thank you for coming and accessing your remote learning from home yet again. This lesson we are looking at testing for positive ions with sodium hydroxide solution. If you haven't done so already, make sure you've completed your retrieval quiz on your student worksheet. So you've got your 10 questions. You need to select the multiple choice answer. So pause this lesson video if you haven't done it already, go and complete it, come back for the answers. So let's go through the answers. What colour flame is produced by copper? Green, well done. What colour flame is produced by potassium? Lilac. What type of loop is used in a flame test? Nichrome. What is the loop dipped in to remove any contaminants? Acid. What colour flame is produced by calcium? Orange red. What ion does sodium form? Now, sodium, remember it's in group 1, so it loses an electron to become just Na+. Monomers join together to make polymers. In a molecule of ethane, there must be 2 carbon atoms. Remember, count them out on your fingers. Meth, F, that's 2. Meth is just 1, meth, F. And it continues, pro-bute, but F is 2. The compounds that names end with ol are alcohols, and describe how a metal atom forms a metal ion. The metal atoms, or the metal atom, loses an electron or electrons and becomes a positive ion. So as I've already said, today we are testing for positive ions, this time with sodium hydroxide. So you need to be able to describe how to identify the metal ions in a substance with sodium hydroxide solution. Now, some keywords. We know what a positive ion is. We know that from last lesson. Remember, metal ions are always positive. A precipitation reaction is a reaction that happens when 2 solutions are mixed, and when they mix, they react to form a solid. And a precipitate, therefore, is the solid that is formed when 2 solutions mix. So last lesson, we looked at how to identify metal ions using flame tests. And remember, lithium produced a crimson red flame. Sodium produced a yellow flame. Potassium produced a lilac flame. And copper produced a green flame. Now, flame tests do have limitations. So some samples contain more than 1 metal ion, and when heated, the colours mix. And this makes it difficult to identify the ions in that mixture, in that substance. So, for example, if you look in that diagram in the top right-hand corner of the picture, you can see that there's a mixture of different colours because there must be a mixture of different metal ions in that substance being heated. And that's why sometimes flame tests can't be used alone. And if we do find that we're getting a flame that has given us a mixture of colours, we then need to do a second test. And that test is to test it with sodium hydroxide solution. And this forms a precipitate, a solid formed inside of a liquid. And the colour of the precipitate can show us what metal ion is inside of that sample. So, testing for positive ions with sodium hydroxide solution. How do we do it? So, we get some sodium hydroxide solution. We use roughly about a pipette or 5 to 10 centimetre cubed, and we add it to a test tube. So we've got a sodium hydroxide solution in a test tube. We then have our unknown sample, our unknown soap solution, and we want to know what metal ion is in that soap solution. So we add roughly the same amount, a pipette full, of our unknown solution. And we then look for a precipitate forming. Remember, a precipitate being a solid forming when two solutions mix and react. Now, in this case, you can see we've got a blue precipitate, a blue solid. Now, I know that a blue solid is copper. It shows me the presence of copper because that blue solid that is formed there is actually copper hydroxide. So what happens is the metal ion in the unknown solution joins with the hydroxide ion in the sodium hydroxide to form a metal hydroxide, and that is our precipitate. This blue precipitate here is copper hydroxide. So I know the metal ion must be copper. So just to go back through that process, you add roughly 10 centimetre cubed or a pipette or quarter fill the test tube with sodium hydroxide solution. You then add a pipette full of the soap solution that you're testing, and then you look for a solid precipitate forming. Now the colour of the precipitate, just like the colour of the flame, can show us what metal ion is present. So let's look at the colours. So this green colour shows me the presence of iron. Now we can also get this browny, orangey brown colour. Now that orangey brown colour also shows the presence of iron. So we've got green and orangey brown, and those two precipitates show me that iron is present. Now the green one is iron 2, so Fe2+. The orangey brown precipitate shows me the presence of iron 3, so iron 3 plus, Fe3 plus ions. And as I told you on the last slide, the blue precipitate shows me that copper ions are present. So iron 2 gives me a green colour. The orangey brown is iron 3. And then we've got the blue colour shows us the presence of copper 2 ions, Cu+2. Now there are 3 other colours and 3 other metal ions you need to know about. So you get magnesium. Now magnesium ions produce a white precipitate. Calcium ions also produce a white precipitate. And aluminium ions also produce a white precipitate. So you've got iron 2 is green, iron 3 is orangey brown, copper is blue. And then the magnesium, calcium and aluminium all produce white precipitates. So what I'd like you to do is your first task is go to the student worksheet and follow the link on task 1 to watch the video on how to use sodium hydroxide to test for metal ions. Okay, so you've watched the video and that leads us on to task 2, which is to remember the precipitate colours. So complete the table by adding in the precipitate colour produced by each metal ion. Now if you're unsure, the colours are in this box to help you. Pause the lesson video, go and complete this on your worksheet, come back for the answers. So let's go through the answers. So copper 2 should have been blue, iron 2, green, iron 3, orange brown, magnesium, calcium and aluminium are all white precipitates. So how do we distinguish between the white precipitates? So if we test a solution and we get a white precipitate, how do we know if it's magnesium, calcium or aluminium? So with aluminium, if we had a white precipitate and we added an excess of sodium hydroxide solution, so we added more and more and more sodium hydroxide solution, eventually, if it dissolves, we know that it's aluminium. So we can distinguish between the free precipitates by adding excess, too much, sodium hydroxide solution, and if it dissolves, we know it's aluminium. And aluminium's ion is Al plus 3. It's in group 3 on the periodic table. It loses 3 electrons. It becomes Al plus 3. So we know now how to distinguish if it's aluminium ions. It dissolves in excess sodium hydroxide, but that still leaves us with calcium and magnesium. So remember, they both produce a white precipitate, but how can I distinguish between magnesium and calcium? Well, then I would need to go back to a flame test. Now remember, calcium produces an orangey red flame, and magnesium ions don't give any flame colour at all. And that's how we would distinguish between the three white precipitates. So if we added excess sodium hydroxide and it dissolved, it's aluminium. If it didn't dissolve, we then need to do a flame test. If the flame is orangey red, we know it's calcium. If the flame doesn't give any colour, we know it's magnesium. So just to visualize these different tests for positive ions, there's a nice diagram. So firstly, we would do a flame test. So if we had an unknown sample and we wanted to know what metal ion was in it, we'd do a flame test. And remember, guys, the flame test, lithium should give a red colour, sodium gives yellow, potassium gives lilac, calcium gives orangey red, and copper gives a green flame. Now we can also do a test by adding sodium hydroxide. So remember, we can do the test for positive ions using a precipitate reaction by adding sodium hydroxide. And the colours can show us what metal ion is present. So if we get a green precipitate, we know it's iron 2. If we get an orangey brown, we know it's iron 3. If we get a blue precipitate, we know it's copper 2. But remember, we can also get free white precipitates. Now, if we add excess sodium hydroxide, NaOH, so if our precipitate is white, we can add excess sodium hydroxide, and remember, if that dissolves, we know it is aluminium. If it doesn't dissolve, we know it must be magnesium or calcium, and then we need to do a flame test to distinguish between the two. So task 3, what is the metal ion being described? So for example, number 1 says this metal ion produces a blue precipitate when added to sodium hydroxide solution. Well, which one gives a blue precipitate? We know it's copper. So pause the lesson video, go and complete this task. If you are stuck, I've given you the answers mixed up in this yellow rectangle at the bottom. So remember, pause the lesson video, complete this task by adding in your answers, come back once you're complete to green pen your work. Okay, so let's look at the answers. So number 1 should have been copper 2, or you might have even written the symbol for the ion, Cu plus 2. Number 2, potassium gives a lilac flame. Number 3, aluminium makes a white precipitate which dissolves upon excess sodium hydroxide, excess meaning too much, adding more. Number 4, a white precipitate that gives an orange-red flame, calcium. Number 5, if it's a green precipitate, it must be iron 2. If an ion gives a yellow flame, it must be sodium. Number 7, a green flame must be copper 2. Number 8, magnesium, because it forms a white precipitate but no colour flame when heated, so that must be magnesium. Number 9, when added to sodium hydroxide, this metal ion produces a brown precipitate, so that must be iron 3. and 10 is sodium hydroxide. So that leads us to our last part of the lesson, the consolidation phase. There are six marks on your consolidation questions today. They are exam style questions. So pause the lesson video, go and complete these exam questions, come back once you have done the task to get the answers. Or to check the answers, I should say. Pausey, pausey, off you go, completey, completey, come backy, backy. Right, number 1. What flame would sodium ions produce? What colour? Yellow. Guys, they would have allowed orange. They would have allowed orange, red, yellow. Kind of them. B, green flame. Should have been copper. C, some fireworks contain a mixture of metals. Why is it difficult to identify the metal ions from the colour of the flame? So they would have allowed a mark for any of these. The colours are masked. The colours might mix or blend. You might only see one colour. You might see two colours at once. Ignore that it's hard to distinguish. So you needed to say that the colours are masked or the colours mix. Number 2, a student tested a metal chloride solution with sodium hydroxide solution. A brown precipitate is formed. What was the metal ion? Well, if it's a brown precipitate, it must be ion free. Question number 3, sodium hydroxide solution was added. A white precipitate was produced. The white precipitate dissolved in excess sodium hydroxide. Well, that must be aluminium. And number 4, the student adds sodium hydroxide to an unknown solution, solution X. A blue precipitate is formed, where if it's blue, it must be copper. That leads us on to the final part of any good lesson. We always review our learning. How well do you think you've met the learning intention? To be able to describe how to identify metal ions using sodium hydroxide solution. So literally, guys, you add your unknown soap solution containing the metal ions to some sodium hydroxide, and you look for a precipitate, a solid being formed. And from the colour of the precipitate, you can tell what metal ion it is. So are you red, amber or green? So complete your RAG rating. Thank you to those of you that continuously, week in, week out, complete your home learning. One more lesson after that, and then you've got your half term, which you deserve a nice break. I know home learning is difficult. It's not the easiest of tasks, especially not having somebody there, a teacher there to support you with your questions or when you're unsure. But hopefully when we are back in school, we can review this and even look at the flame tests and the precipitation reactions to show the metal ions.